On September 23rd, 1999, something unbelievable happened. A spacecraft worth $327 million was approaching Mars. It had traveled hundreds of millions of kilometers through space. For months, engineers at NASA had been waiting for this moment. Everything seemed to be going exactly as planned. The spacecraft was almost there. After years of designing, testing, and countless hours of work, humanity was about to place another machine into orbit around another planet. But then, something went wrong. The spacecraft disappeared. There was no explosion, no warning, no dramatic failure. One moment, NASA was expecting a historic success. The next moment, one of its most expensive missions had vanished. And when engineers finally discovered what happened, the reason seemed almost impossible to believe. The spacecraft was not destroyed because of some advanced technological failure. It was not attacked by radiation. It was not damaged by a mysterious problem in deep space. It was lost because two teams building one of the most advanced machines in human history were using two different measurement systems. A mistake involving something as simple as units. A mistake that cost NASA $327 million. But the most surprising part of this story is not that someone made a mistake. Mistakes happen. The surprising part is that some of the smartest engineers on Earth failed to catch it. And this failure would become one of the most famous examples of how even the greatest scientific organizations can be defeated by a simple human error. In the 1990s, NASA was entering a new era of exploring Mars. For decades, sending spacecraft into space had been one of humanity's greatest technological challenges. Mars was especially difficult. The planet was close enough to study, but far enough away to create enormous problems. A spacecraft traveling to Mars could not simply fly directly toward the planet. Engineers had to calculate the exact path, speed, and timing. A tiny mistake at the beginning of the journey could become a massive error millions of kilometers later. It was like throwing a ball from one city to another and trying to hit a target only a few meters wide. Except the ball was a spacecraft, and the target was another planet. NASA wanted to make Mars exploration faster and cheaper. Instead of building one extremely expensive spacecraft every decade, NASA created the Mars Surveyor program. The idea was simple: build smaller missions, launch more often, learn faster. One of these missions was called the Mars Climate Orbiter. Its mission sounded ambitious. The spacecraft would travel to Mars and study the planet's atmosphere, climate, and weather patterns. Scientists hoped it would help answer important questions. How did Mars lose much of its atmosphere? Could Mars once have supported water? What can the planet's climate tell us about Earth's own future? The spacecraft itself was a masterpiece of engineering. It carried advanced scientific instruments. It contained powerful computers. It was designed to survive a journey through one of the most dangerous environments imaginable. Thousands of people contributed to the mission. Scientists, engineers, software developers, manufacturers. Every single part had to work perfectly. Because in space, there is no repair crew. There is no emergency button. Once the spacecraft leaves Earth, the decisions made on the ground determine everything. The Mars Climate Orbiter was launched on December 11, 1998. At first, everything went perfectly. The rocket carried the spacecraft into space. The spacecraft separated successfully, and soon it began its long journey toward Mars. For the engineers watching from Earth, this was the beginning of a 7-month wait. During that time, the spacecraft traveled through the darkness of space. Every day, NASA received information from the spacecraft. Engineers carefully monitored its position. They calculated its speed. They checked whether it was following the correct path. Small corrections were made along the way. This process was called trajectory correction. Because even a tiny deviation could send the spacecraft millions of kilometers away from its destination. Imagine driving across an ocean toward a small island. If your direction is wrong by just a little bit, you may never reach the island. Space works the same way. The spacecraft had to arrive at exactly the right location. Too far away, and it would miss Mars. Too close, and it could be destroyed. For months, everything appeared normal. The spacecraft was moving closer and closer to its destination. The engineers had every reason to believe the mission would succeed. Then came September 1999. After a journey of nearly 10 months, the Mars Climate Orbiter was finally approaching the red planet. This was the moment everyone had been waiting for. The spacecraft was about to perform one of the most important steps of the mission. It needed to enter orbit around Mars. If successful, it would begin sending back valuable information about the planet. Inside NASA's control room, engineers watched the data carefully. The atmosphere was tense. Years of work were about to be tested. A spacecraft built by some of the world's best scientists was about to arrive at another planet. Everything depended on a few final calculations. The spacecraft approached Mars. Then, it disappeared behind the planet. Normally, this was expected. The spacecraft would temporarily lose communication as it passed behind Mars. Engineers waited. They expected the signal to return. Seconds passed, then minutes. But something was wrong. The signal never came back. At first, the team believed it might be a temporary communication issue. Maybe the spacecraft had entered the wrong orientation. Maybe there was a problem with the antenna. Maybe the signal was simply delayed. But as time passed, the possibility became harder to ignore. Something had happened. The Mars Climate Orbiter was gone. A mission that had traveled hundreds of millions of kilometers had failed in the final moments. The room that had been filled with anticipation became silent. NASA had lost contact with a spacecraft worth hundreds of millions of dollars, but nobody knew why. The engineers began searching for answers, and what they discovered would reveal a mistake so simple that many people could hardly believe it. Because the failure of the Mars Climate Orbiter was not caused by a complicated space problem. The problem had started much closer to Earth. It started with something humans had been dealing with for thousands of years, the way we measure things. At first, engineers searched for the usual explanations. Maybe there was a hardware failure. Maybe a computer malfunction had corrupted the spacecraft's systems. Maybe a mistake had been made during the final approach. But as teams analyzed the data, they discovered something strange. The spacecraft itself was not the problem. The rocket launch had been successful. The communication systems were working. The spacecraft's computers were functioning. The failure came from something much more unexpected, a disagreement between two different teams. And hidden inside thousands of lines of engineering data was a small but catastrophic difference. One team was using the metric system. The other team was using the imperial system. More specifically, one piece of software was calculating engine thrust using pounds of force. But the navigation team expected the data to be measured in newtons. The difference seemed small. After all, both systems were describing the same thing: force. But in space exploration, small differences can create enormous consequences. The navigation team was using this information to calculate the spacecraft's position. Every correction they made was based on these numbers. But because the numbers were interpreted incorrectly, the calculations slowly pushed the spacecraft onto the wrong path. The mistake was not dramatic. There was no single moment where someone pressed the wrong button. There was no obvious warning. Instead, the error quietly traveled through the system, day after day, calculation after calculation, until the spacecraft reached Mars. By then, the mistake had become impossible to fix. The Mars Climate Orbiter was supposed to pass Mars at an altitude of about 140 to 150 kilometers above the planet's surface. That was the planned trajectory. But because of the incorrect calculations, the spacecraft approached much closer than expected. It entered the atmosphere at an unsafe altitude. At that point, NASA had lost control of the situation. The spacecraft either burned up in the Martian atmosphere or passed into an orbit around the Sun, leaving Mars behind forever. A machine that had traveled hundreds of millions of kilometers had been lost because two groups of highly skilled professionals were speaking different measurement languages. When the investigation was completed, NASA released its findings. The official conclusion was not simply that someone forgot to convert units. The deeper problem was much larger. The failure happened because the entire system allowed the mistake to survive. A spacecraft mission is not created by one person. It is built by thousands of people working across different organizations. One group designs hardware, another writes software, another analyzes data, another controls the mission. Everyone is an expert in their own area. But complexity creates a dangerous situation. Sometimes everyone understands their own part perfectly, while nobody sees the entire picture. The engineers working on the mission were not careless. They were not unqualified. Many of them were among the best scientists and engineers in the world. The problem was that the system depended on communication between many different parts. And somewhere along that chain, the meaning of a number was lost. A number that one team understood one way was understood differently by another, and nobody noticed until it was too late. The Mars Climate Orbiter accident became a powerful lesson in engineering because it revealed something uncomfortable. The biggest failures in complex systems are often not caused by a lack of intelligence. They are caused by small assumptions. People assume that someone else checked. People assume that everyone follows the same standard. People assume that a simple detail cannot possibly destroy a billion-dollar project. But history has shown that simple details can become the most dangerous ones. A missing inspection, a misunderstood instruction, a forgotten conversion, a small error repeated thousands of times. The more complicated a system becomes, the more important the simple things become. Interestingly, this was not the first time different measurement systems had created problems. Throughout history, humans have struggled with standardization. Different countries developed different ways to measure distance, weight, and temperature. For everyday life, these differences are usually just inconvenient. A recipe might need adjustment. A person might need to convert miles into kilometers, but in aerospace, there is no room for confusion. A spacecraft does not know whether a number came from the metric system or the imperial system. It simply follows the instructions it receives. And that is why communication is just as important as technology. The most advanced machine in the world is still controlled by humans. After the Mars Climate Orbiter failure, NASA made changes. The agency reviewed its procedures. Teams improved communication between contractors. More careful checks were added to prevent similar mistakes. The failure also became a reminder for future missions. Space exploration is not only a battle against physics, it is also a battle against human error, because rockets and spacecraft are built by humans. And humans, no matter how intelligent or experienced, can make mistakes. The difference between success and failure is often whether a system can catch those mistakes before they become disasters. Years later, NASA continued exploring Mars. Other missions succeeded. Robotic explorers landed on the surface. Scientists learned more about the planet than ever before. The loss of the Mars Climate Orbiter did not stop humanity's curiosity. Instead, it became part of the long story of exploration, a reminder that progress does not come from never failing. It comes from understanding failure, because every great achievement in human history was built by people who made mistakes, studied them, and improved. The story of the Mars Climate Orbiter is not really a story about a unit conversion. It is a story about something much bigger. It is about the limits of human systems. It is about how thousands of smart people can create something extraordinary while still being vulnerable to the smallest details. And perhaps the most important lesson is this: the most dangerous mistakes are not always the ones that look impossible. Sometimes they are the ones that look too simple to matter. A spacecraft can travel across the solar system. A team can solve problems that seem impossible. But in the end, a single misunderstood number can decide everything. Because even at NASA, even among the greatest engineers on Earth, human beings are still human. And sometimes, the smallest mistakes create the biggest stories.